Thank you, folks. So now we're going to talk about what's new in MySQL, right? And when I say what's new in MySQL, we're mostly covering things which we are done since last Cloud World. There may be some overlap, but we're trying to keep the content to be content since last Cloud World. So the first thing which we are very excited about is the LTS release, right? So over the last many years, we have heard from customers, on-premise customers, as well as the cloud customers, that they want a release which we don't make any changes to, right? Because we want to add new features, but at the same time, there's a class of applications, even within an enterprise, where they just want to make sure that they get the upgrades from which has all the security patches or the CVEs, but it doesn't have any features, because anytime you're adding a feature, there could always be some risk of change of semantics or some enhancements which may break compatibility and such, right? So what we have is, just yesterday, we released our first LTS release, which is 8.4. So this is a release on which we are only going to make security fixes or very absolute must fixes. And so if customers want a long-term support, this is a release to be. Starting in mid-July, we will have the next release, which is going to be the series of these innovation releases, which we're going to start off with 9.0, right? So this will be the start of 9.0 in July, where we will have a bunch of big new features, which we will be announcing. The LTS for the 9 series is going to be 9.7, and that's going to happen in about 2 years, right? So that's the first thing with respect to the overall release cycle of MySQL. I'm going to talk about assortment of projects, right? But they really cover these 5 categories, right? One is improving the performance. Now, in the context of the cloud, many people say that, hey, the only thing which matters is price performance, which is very true in the context of the cloud. But even for on-premise, performance is very important, because when you're running an application, you're running an application on a certain amount of hardware. As your workload increases, as your application demands change, you have one of 2 choices. Either you move or you upgrade to a larger hardware, which is going to cost you more, or we make the software more efficient. That's why every release we now are going to track how are we doing with respect to performance, right? So I'm going to talk about a bunch of things with respect to improving the performance and scale. The second thing is lowering cost. We are always looking at ways such that for existing workloads, customers can potentially downsize, right? And a good example of that is auto-indexing, by the way, right? Because that gives customers idea that, okay, you know what, if their workload has changed, do they really need to create these indexes? Because that will have an impact, right? So that's the second aspect, lowering the cost. Third is developer productivity, right? Not only is MySQL the most popular open source database in the world, it is even more popular amongst developers. There are many things about MySQL which we can improve, for instance, having a more sophisticated optimizer. But the one thing which is really, really good and loved by people about MySQL is that it's very easy to use. It's very simple to use. So it's very popular with developers, and we want to continue that. The next is security. The next is security. That's always important, and then we'll talk about a few things which we are doing to improve that posture. And finally, high availability. Look, both for the cloud and for on-premise, we have a lot of customers, but the ones who are depending on MySQL for running their enterprise, for running their system or the mission-critical applications, we really, really strive to make sure that we don't turn them down, in the sense of we don't disappoint them. And if you ask any of these large customers what is the thing they need, sure, security is the most important thing, but what they really need is high availability or high uptime. That's what customers mostly need for mission critical applications. That's true for MySQL, that's true for Oracle database, that's true for most databases, right? So this is an area which we have already always talked about, but this is something which we're going to double up and have even more emphasis on. So now let's talk about the features. So the first thing is about the thread pool, right? Thread pool has always existed in MySQL Enterprise Edition for a long time. So what is different now? Well, what I'm showing in green is basically the graph which customers get, not just with the community server, but also with other databases like Aurora. So what is happening in this case is that as you have more concurrency, the system is able to handle these concurrent requests and keep increasing the throughput up to a certain point. But once it reaches a certain threshold, then the throughput starts dropping. Now, why is the throughput dropping? Well, the reason the throughput is dropping is because there's a lot of contention, right? So what we have done is something, at least conceptually, it's very straightforward, is that once we figure out that, okay, this peak has been reached, or there is a slight reduction in the throughput by adding more transactions, we basically start doing an admission control. So we say, you know what, beyond this point, we're not going to admit any more transactions until the transaction is complete. That's basically, in a nutshell, what we have done. But it's not as straightforward as that, because there's also an aspect of fairness. Because you could have just one last transaction which comes in, which completely hogs up the entire CPU, and then what do we do, right? So we need to have some balance as well between long-running transactions as well as short-running transactions, right? But by doing this admission control, we are able to minimize the contention of the resources, which is why the throughput of the system gets to be steady. It does not drop. Right there you can see the value over here. If you were running it on an on-premise system without the enterprise edition, or if you were running on some other cloud service like be it Aurora, be it RDS MySQL, as your throughput starts decreasing, what are the choices you have? You'll have to upgrade to a larger machine. With MySQL HeatWave, you will not have a degradation in performance. Your performance will be steady. And at that point, you can decide whether you really want to increase your load further and increase the performance further. But the throughput will not drop. Right? So that's the first thing, which we call actually auto thread pool. The second thing, and Wim alluded to is that earlier in his talk, is that now we are having a lot of synergy with the underlying operating system and specifically Linux. MySQL has had this issue in InnoDB where we do double writes, and this is because of the issue of the tone writes with the operating system. So now we have this primitive from Linux which we use in InnoDB. As a result of that, we are able to reduce the amount of writes and the latency by half. Right? So what this graph is showing for atomics, by eliminating the double buffer writes, we see that the amount of data which is being written has reduced to half, and the amount of time it takes for committing the write has reduced to half. From an end-to-end performance perspective, right? So these are some end-to-end queries we have taken, where we have the write statements executing. What this graph is showing that there is absolutely no difference in performance with the fix as well as compared to the case when the double writes were off, right? Because if you have the double writes off, it can lead to some semantic issues. So just from test purposes, we turn it off and we see that the performance is identical. So this is something which we have completed in development. We are just waiting for that Linux fix to be rolled out, and at which point this fix will also be rolled out. But this is something which has been done, tested. Now, one of the things about MySQL, and when we talk to our customers, right, is that the performance of loading data into MySQL is slow. Well, one thing you have to realize why it's slow. One of the reasons it's slow is because MySQL only has IOTs, or index organized tables. It does not have heap tables. Now, so one is this, right? Because as you're inserting the data, you're building the IOT. But the second thing is to parallelize creation of this IOT also takes a bunch of effort. That's what we have done. We are now able to bulk load data into MySQL InnoDB system by creating multiple trees in parallel and then merging them in parallel. Right? So that's work we have done. Now, so 3 steps are, we first do a parallel sort and merge, right? So we are building these subtrees in parallel, and then we kind of merge them together. Now, one thing you have to keep in mind is that this is something which is work in progress, right? We are supporting it for a bunch of data types, but there is more work to be done. And one big limitation right now is that this does not work in the presence of binlog. Right? So this is something which over time we are going to address. But the question is, what is the kind of speed up we get with this? Well, the speed up is about an order of magnitude. And the larger the data size, the more the performance improvement is going to be. So the 2 advantages here are, it's going to be much faster to load data into InnoDB, into MySQL. But the second thing is, it also reduces the amount of memory which is consumed. And this again comes down to cost, right? That if you're now running a system which requires less memory, if you're on-premise, guess what? You have to provision a smaller box. If you're in the cloud, guess what? You have to provision a smaller machine. So many of these things which we are doing have 2 dimensions. A, it's providing you better performance, like 10 times like speed up, that's great. But the second thing which you're getting is indirect cost, that you do not need to upgrade to a larger shape. Right? Again, I just want to make sure that you understand that this is still work in progress. It's not to say that bulk load works for all the scenarios, but we have gotten started. We have done the heavy lifting of making sure we can create these subtrees in parallel and merge them, and now we're going to enable it for more and more use cases. The third thing is, we got a lot of feedback from our customers that while we were innovating, very briskly over the last several releases, there were many scenarios in which we were actually introducing some regressions. Right? Now, in some cases, they were not regressions. It was the case that this was change in behavior for a good reason. But never mind that, we went through all the bugs which were reported in terms of any performance issues, and now we're just addressing them one after the other. So please note, these are not all regressions. Many of them are now enhancements which we are doing based on the customer request. And we have 18 fixes which we have already made, which are going to be available in the 8.4 LTS release. Right? So this is something which over time we are just hoping that you will experience, that 8.4 will be not only just a more robust release, but it's going to be a more performant release as well. Now let's talk about Autopilot indexing. Now for any OLTP system, it is expected, for any OLTP system, what matters is the latency, not the throughput. People want the results of the queries to be really fast. And the very obvious way of doing that is to create indexes. So unlike analytic systems, for OLTP systems, people always create indexes. Now there are a couple of challenges. One is, how do you know which columns to create indexes on? You can say, you know what, I'm going to create the indexes on the columns on which there are queries. Well, but then it's going to hurt the DML performance. And what if the workload changes? Right? So being able to automatically recommend which indexes to create is something which is very, very useful in practical scenarios when the workload is changing. If your workload was static, sure, you can design the schema once and be gone. But that is really the case. The workload changes. So as the workload changes, you will have new queries which may be better off if you were to create indexes on those appropriate columns. Right? Or it may be the case that your DML performance is going to hurt because now suddenly the system has more DML activity. So what Autopilot indexing does is that it uses machine learning to not just predict which indexes to create or which indexes to drop, but it also predicts what is going to be the improvement you're going to get. So this is one thing I want you to really understand about MySQL HeatWave and MySQL Autopilot. Not only are we making all of these machine learning capabilities available to our end users so that they can build new applications using these machine learning capabilities, we are internally significantly using machine learning to automate various aspects of query processing, and this is just a start for data management. And the advantage of machine learning is it can adapt to the changing workloads. The second thing is it can help predict what the improvement is going to be. This is something which a rule-based systems cannot do. So we have customers who are trying this Autopilot indexing and seeing benefits. But to me, what the litmus test is that you take benchmarks, OLTP benchmarks which have been tuned, and then you run Autopilot and see that, hey, does it make the same recommendations or different recommendations? Right? So the first thing I want to note is that in many of these cases, we have, in all the cases we have seen so far, Autopilot makes the best recommendations, and we are always meeting the performance of a well-tuned system. That's one part. But the second part is, in some cases, we are actually doing better. And how is that? Well, the reason we are doing better is because some of these tuned benchmarks were only focused on the query performance. What we want to look at is not just the query performance, but also the DML performance and the aggregate throughput. Right? So this is very, very interesting, that not only are we good for realistic workloads where customers don't know what the optimal schema design is, but even for the well-tuned benchmarks, we are at par, and in a few cases, even better. Now, let's come to the next segment, which is improving developer productivity. There are many advantages of having stored procedures run inside the database, right? Because you're bringing the logic or the application logic closer to the data. So that minimizes data movement, that reduces cost, because instead of requiring a client doing this processing, you can now do all this processing inside the server. It improves security, again, because there is minimal data movement and such, right? So stored procedures have always been very popular with most databases. However, so far we have had SQL store procedures, which are fine for a lot of use cases. However, JavaScript is not only the most popular programming language, scripting language, it has a lot of benefits in the context of the database. For one, we have a lot of customers who store their data in a MySQL database, but then have some client where they extract the data from the MySQL database using a JavaScript application. Right? Now guess what? All of this logic can be pushed inside the server. And by doing so, not only do they get better performance, but they also lower the cost. We have a customer, in fact, they're in the Bay Area. This feature is still beta because we are going to go GA with 9.0. They said, you know what, this works just fine. And by doing so right away, they were able to save so much of cost. So we have customers who have gone production with this feature just because of the significant amount of cost savings they already achieved. Right? And then there are other aspects in terms of expressiveness. I mean, JavaScript is obviously much richer in terms of what you can express compared to SQL. There's a much larger ecosystem of applications with JavaScript, right? So those are all the other benefits. But this by itself significantly enriches the value of the server, because many of these applications, not just for MySQL but for other databases, use JavaScript to manipulate the data by fetching the data outside. Now all of this logic can be done inside the database. So lower cost, less data movement, better performance, more secure, works with a much larger ecosystem of applications who are directly now talking or can talk to the database. Now, how did we do this? Well, it would take us years, if not decade, to build a good Java runtime, or JavaScript runtime. So what we are doing is we are using this engine called Graal VM. It's a polyglot. And the good thing is that once we have integrated this runtime into MySQL, there's an opportunity in the future that as we want to have support for other languages, it becomes much easier. This feature is available both on-premise as well as in the cloud. For developers who want to use this thing, we are making the Enterprise Edition of MySQL available in OTN. So this feature exists in Enterprise Edition. If developers want to try it out, they can download this, the Enterprise Edition from OTN and try it for themselves. We have made extensive changes to the MySQL engine to support this JavaScript as a first-class object. What that means is you can pretty much use it anywhere where SQL stored functions are used, in select, in DMLs, in views, in DDLs, and such. The second thing which we have done for JavaScript, and this is actually a big new part we have done in the last few months, is that we have had to modify the SQL server so that it can call out while it's executing. Now, by doing so, what we can now support is SQL callouts from JavaScript, right? So if you're doing processing in JavaScript, not only are you executing some procedural logic, you may want to fetch the data from the database, and that's what this thing enables you to do. You're always conscious about performance, that sure, you're providing a lot more richer functionality, you're moving the compute from the client to the server, but is it something which would regress the performance of an existing OLTP application which is running? So what this graph is showing is that the performance of running JavaScript inside the server versus running a SQL store procedure in terms of the noise to an existing OLTP transaction is identical, meaning there is absolutely no overhead we're introducing. Right? And the other thing to point out from a security standpoint is this whole runtime, the Graal runtime, is in a sandbox. Right? So if there's a crash in the Graal engine or the Graal VM, that is not going to impact the MySQL instance. All the capabilities of MySQL and MySQL HeatWave, transactional processing, analytics, machine learning, Autopilot, generative AI, they're all available as a REST endpoint as well. The next thing is, from a developer productivity, we are now significantly investing on the client side to make it easy for customers to use either MySQL Shell, the VS Code plugin, not just for the capabilities which exist in MySQL, but also in HeatWave. Right? So like as earlier you saw in Wim's talk, we're extending it not just for HeatWave, not just for Lakehouse, but even for the latest features like generative AI. The next thing is, when it comes to, again, you can call it ease of use, but also like adhering to standards. For any database, anywhere, and MySQL is no exception, one of the things which is very important is that we can say, hey, you know what, we are improving the performance of the system. We are making it less expensive to use, or we are utilizing the resources more efficiently. but customers need to monitor it, right? So there again, we are making a lot of investments. One such area is support for open telemetry. This has been a very, very sought after thing. The reason is, sure, we are offering our tools and we are making them even better. For instance, we have now support for the enterprise manager, which is going to work with MySQL. However, customers want the ability where they can get the telemetry from the MySQL instance in a standard format and perhaps use it with their own tools. This is one of the reasons we have provided support for open telemetry. The next thing is the data management service, right? So the way to think is, this is a very, very attractive thing at Oracle. Most of the customers of the Oracle database, both on-premise as well as in the cloud, use this service. So in a nutshell, what we have done is we have provided well, at least a roadmap, right? But majority of the database management capabilities, which is available to our customers for the Oracle database, now extending it to MySQL. This is a very, very big deal, right? So we've had some tools in the past which we have improved and such, but this is almost taking it to the next level, right? So we are offering the database management service, which has a lot of capabilities like monitoring, predictive insights and such, both for the on-premise case and for the cloud case. Security. We have introduced support for bring your own certificates. So what this does is that customers can now create or provision using like the OCR services which generate the certificates. OpenID, right? So this is again one of those things which the OpenID Connect standard. So if there are customers who have been authenticated with OAuth, they can now use this thing in a fairly straightforward manner. Now high availability. So as I said, when it comes to most of the large customers who are building their mission critical business on MySQL, if there is one thing they need apart from security, that's high availability. And that's something which we're going to continue to improve upon. But the first thing is, for the MySQL service in the cloud, we have significantly cut down on the downtime, right? So the planned upgrade, which used to take about 60 seconds, is now down to 15 seconds. The planned switchover, if you're going from a primary to a new primary, that's cut down from 60 seconds to 7 seconds. If there's an instance or a secondary which has gone down, we automatically detect that the secondary has gone down and recover it. And then finally, being able to make changes to the secondary in an online manner, both the configuration changes as well as the shape changes. This has been a very, very sought after feature by our customers, and that's something which is now available. That's for HA. Now for the read replicas, because a lot of customers use read replicas both for on-premise as well as for the cloud to get better read performance. Same thing which we did for HA systems, right? Changing the shape, changing the configuration, changing the version. These can all be done in an online manner in our service now. Point-in-time recovery. Well, we'll get to the performance improvements in the point-in-time recovery itself, but just the process of uploading a bin log, right, which is necessary for the point-in-time recovery. The observation was that right now it was taking, some amount of time. Now, if it's taking too long, not only does it cause a botheration to the customer saying it's taking too long, but it increases the vulnerability window, because if it's taking, say, 10 minutes to upload the bin log, during that time if there's a crash, right, the customer is really out of luck. So there are two advantages of improving the bin log upload time. One, it just improves the performance. So instead of, say, 15 minutes, which the customer had to wait, now they need to wait only for 3 minutes. That's one aspect. But the second and the more important aspect, in my opinion, is that the vulnerability window has now significantly shrunk. So that was for the bin log. Now in terms of the point-in-time recovery itself, right? So there are two key things we have done. One is we are now applying this the point-in-time recovery in a multi-threaded manner, and by doing so, we have improved the performance almost by 2 times. Secondly, because of a variety of reasons, people may want to disable point-in-time recovery, and one of the things we found is that disabling the point-in-time recovery earlier was taking almost half an hour, which can be annoying, saying, hey, you know what, I'm running out of space, I don't turn it off, taking half an hour is too long. This is something which we have now shrunk to about 3 minutes. So kind of to recap about MySQL and MySQL HeatWave. MySQL is designed for transaction processing, right? So a lot of customers worldwide use MySQL when they want mission critical applications, they want transaction processing applications with MySQL. However, if customers have the need to take the data and to run analytics, or to run machine learning, or to run generative AI, or they want to now process unstructured data, instead of going to other services, if they are using the MySQL cloud service, which is MySQL HeatWave, they get all of those benefits without ever having to move the data. So the data is in MySQL. Use it for migrate your existing OLTP applications. You get whatever value you get from them. But now when the time comes to get more value, right, all of those are available without requiring any upgrade, without requiring any data movement. And as I was talking about earlier, not only do we provide analytics or machine learning or vector processing, it is the best performance in the industry. And the other thing is to highlight is that when we talk about capabilities like Autopilot, right? So I talked about one feature today, which is like the auto indexing, but there are other features we have. For instance, auto shape prediction, right? Auto thread pool. The improvements which we make in Autopilot. So Autopilot is our machine learning based automation. This is available not just for analytics or not just for Lakehouse, but it's also available for transaction processing. And going forward, you're going to see more and more features in this space. So with this, thank you so much for your time.